So when doing measurements in science, it is crucial to indicate what your uncertainty in that measurement is. Every measurement, you got to tell us how uncertain you are. And you may be saying, oh no, you mean I got to do something extra for every measurement? You really don't if you are measuring with the proper precision. The way we do that is using significant figures. You can call them sig figs for short. We're going to introduce these today. The big idea with sig figs, you call them significant figures, you call them sig figs, is that the measurement 8.9, 8.90 centimeters, and 8.900 centimeters all mean different things. You may say, aren't those all just 8.9? They're not. They're equal, but they have different uncertainties. We have a different level of uncertainty for each one of these. So the difference is that you are claiming different uncertainties. Whenever you write down that last decimal place, you are making a claim. Now, if you wrote the measurement as 8.9 centimeters, then you are making a claim that the last digit you wrote, the 9, is the only one that's uncertain. We call that the first uncertain digit. So if you say 8.9, you are saying it might be 8.8, it might be 9.0, but it's 8 point something for sure. The only one that's uncertain is the 9. So if it could not, you're saying it cannot be 10.8, you're saying it can't be 7.4, you're saying it's 8.9, that 9 is the one that could go up or down a little bit. If you wrote it, however, as 8.90 centimeters, you are saying something totally different. And this is the important part to get. When you say 8.90 centimeters, the last digit you wrote, which is that 0 right there, this 0, you are claiming that the 0 is the first uncertain digit. That means that it might go up to 8.94 or 8.95. It might be as low as 8.85, but this is the one that can go up only up or down a few hundredths. You're saying you know it pretty well. You know it. You know the ones place. You know the tenths place. You're only uncertain about the hundredths place. The first uncertain digit is in the hundredths, so that's the only one you're not sure of. If you wrote 8.900, and this is the problem that some kids were having when in our just demo that we just did, they were writing down too many places. If you write down 8.900, you're saying that this second 0, this 0 right here, is the uncertain digit. So you're saying it's for sure 8, it's for sure 9, it's for sure this first 0. It might be 8.904, it might be 8.896, but you're saying that it can only go up or down by approximately a few thousandths. These three numbers mean different things. They mean the last digit you write down is the one that you're unsure about. We call it the first uncertain digit. Now let's go ahead and try this, you guys. What is the first uncertain digit in 4.6? So the first uncertain digit, we'll just do it together here, is the last one you wrote down. It was the 6. What is the first uncertain digit if I measured 4.62 centimeters? Go ahead and write that in to see if you get this right. And I don't need any decimal places, just which digit is it. What's the last digit there? It's 2. The answer should be 2 right there. Finally, what is the first uncertain digit in 4.620? Which one of those digits is not certain? Go ahead and write that down. And if you said, hey, it's got to be the last one, which is 0, you are right. So that's the first step, is to understand what that uncertain digit is. You guys, it's super easy. The last digit you write down is the first uncertain digit. All the rest you got to be very, very confident of. It's that last one that you can take an estimate of. Any questions on that part, what the uncertain digit is? Simple way to say it is, the uncertain digit is the blank one you write down. Can anybody help me with that? The uncertain digit is the blank one you write down.
The last one?
The last one you write down, that's all it is. Okay, now let's go to the next step. This is the idea of uncertainty that the College Board uses. And the reason I use the College Board standards is because they write the AP exam, they write the SAT, so they need you to understand this for science classes and science APs. The College Board they use the common convention is what we all agree on, that the last digit you write down in a number, the first uncertain digit, may be off from the true measurement by no more than plus or minus 5. If you put down that last digit, you're saying, I guarantee I'd make that digit higher by 5, I make that digit lower by 5. That real answer is between those two numbers. So when you write down a measurement saying 2.37 centimeters, that means more than you used to think it means. It means more, I think it's 2.37 centimeters. You are making a claim about the uncertainty. You are claiming the first uncertain digit is the 7. It's the last digit, right? It's the, and we're saying the first uncertain digit is in the hundredths place. We are claiming that this measurement, that's the real measurement, that's like what we're really trying to measure, the true measurement could be different from this value by up to 5 hundredths because the uncertain digit is in the hundredths place. So we're saying we might be wrong by 5 hundredths, not 5 thousandths or 5 tenths, but 5 hundredths. You are claiming an uncertainty of this number. You guys, how would I say that number if I was using the word hundredths? How many hundredths is that? It's 5 hundredths, right? So you're saying that your uncertainty, because you put the last digit in the hundredths place, you're saying the uncertainty is 5 hundredths. And this number is always 5 of something. It's the College Board standard. And when you write 2.37, you're saying, I guarantee the true measurement is between 2.32 and 2.42. How did I get those two numbers? Where did 2.32 and 2.42 come from?
By subtracting 5 hundredths from 2.37, your estimate.
Yeah, you just take this number, you subtract 5 hundredths, you add 5 hundredths, and that is the range. Okay, by contrast, this is different, you guys. If you said the measurement was 2.370 centimeters, you're claiming the zero's uncertain, and it's in the thousands place, so you're saying this is the uncertain digit. So that means you're saying the true value could differ by 5 thousandths. How do we know that this person's claiming that this number might go up or down by 5 thousandths? What's the key to this number that the person is, just by writing that down and writing down nothing else, they're claiming that their uncertainty is 5 thousandths? What is it about that number 2.370 that says the uncertainty is 5 thousandths? Can anybody help me on this? What is the first uncertain digit? Can someone help me on that one?
The 0.
What place is that in? The 0. That's in the thousands place. That's how we know. The College Board says whatever you put down that last digit, that's your uncertain place, and that digit can go up or down by 5. That's it. So they're saying the true measurement could be 2.365 to 2.375. How did I get those two numbers? You guys, where did those two numbers come from? 2.365 and 2.375.
By adding 5 thousandths and subtracting 5 thousandths from the original number.
From your measurement. This was your original measurement. When you write down that 0 right there in the thousands place, you're saying, I'm guaranteeing that my number is between these two values. So let's go ahead and try a couple more of these. Okay. And somebody said there might be an error, so we can fix those as we go. If you are assuming you're using proper sig figs, now these actually count. Sig figs will count on these. If you measure a wire to be 8.3 centimeters long, you're not just saying, I think it's 8.3. You're saying, I guarantee it's between what and what. So let's try it together. You guys, what's the uncertain digit? Which place is it in?
The 10.
The 10.
It's in the tenths place. So this number can go up by how many tenths?
5 tenths.
5 tenths. So that would be, what would I get? 8 point what?
8.
8.8 there. That's, sorry, I want to go to the lowest one. You got to go lower. Sorry, it's 8.3. We got to write it this way. We're saying it's 8.3 centimeters plus or minus 0 point what? 5. See, this is the uncertain place. Our uncertainty's got to be in that tenths place also. That's just one way of writing. What's the range of values that we're saying it must be between? What's 8.3 minus 0.5?
7.8.
7.8 centimeters. And it's got the highest possible length would be 8.8 centimeters. No, so you must have, and let's go ahead and press submit to make sure that's right. Okay. And then if there's a mistake in here, I'll fix it, but whoops. Okay, we got all those right. Let's try this one. If you measure a dowel rod to be 0.763 meters long, then you're claiming a measurement plus or minus uncertainty of, so what are we saying is our best guess? That goes here. You just rewrite it, 0.763. We think that's the right answer, meters. But if you write it like this, where's the uncertainty? What place is the uncertainty in, folks?
The thousands.
Thousands place, that's the last digit. So that means it could go up or down by 0. What do I got to write in here if the uncertainty is in the thousandth place?
0.5.
That would be the hundredths place.
Oh, 0.05.
Yeah, 0.5, and there should not be a dot there. Okay, there we go. So that's our right answer right there. Notice it always matches up in the last decimal place. That means your lowest possible length could be 0.760. No, 755. Can't type. 755. And the highest possible length would be 0.765. Okay, let's see if that one works. And these are all the same
Mr.
here.
Barkley?
Yes.
Um,
Oh, forgot my units. It's 7.755 meters and 7.565 meters. Okay, you guys, so you see that I'm going to make mistakes just as many times as you guys are. That's why when you only have 5 free submissions, if you are stuck, see me when you get 3 submissions because then I'll get it wrong once and then we'll get it right together. Okay, now we're going to try this here. And this is where we're going to really see the difference. If you measure a table to be 1.24 meters tall, you are claiming a measurement plus or minus uncertainty of blank. Now, let's go ahead and try this. 1.24 simply means 1.24 meters. That means the same thing. Got to put in my units are already there. That means it's plus or minus how many watts? What do I got to do right here? 0. What?
0.5.
0.5. Notice it's in the hundredths place. 0.5. And that means my lowest possible height is 1.19 meters. You got to put in a space here. And this is 1.29 meters. Those are the range. So far, so good. Here's the difference. If you measure the table to be, instead of 1.24 meters, 1.240 meters tall, you are making a different claim. That's saying something totally different. You are saying it's 1.240 meters plus or minus. What is going to be the difference for this one? And I got to call on some folks that don't have their cameras on. So if you want to avoid this, you can just turn your camera on. I will not call on you. Emmanuel, what do you say for that one? What would be the plus or minus box? What would go in there?
It would be 0.005.
You are absolutely right. You see how it's the same place? It's the thousandths place. You got that absolutely right. So that means notice we're saying there's less uncertainty. So you just subtract this. I'm getting, notice we're claiming this is between 1.235 by subtracting 0.005, and the highest possible one will be 1.245. Notice the difference here between this and this and this and this. This is a smaller range. 1.235 to 1.245 is smaller range of uncertainty than 1.19 to 1.29. Let's make sure I got that right. Okay.
I forgot unit.
Oh, thank you. Yep, you're absolutely right. And you guys are going to catch me making tons of errors and got to put in the units there. Thank you for that. Okay. And let's see if I got it right now. You guys, the rest of them I'm going to leave for you. But the next fun thing we're going to do is actually learn how to measure with one of these bad boys, one of these rulers.